Hello students, in this session
Let us solve a question on columns. The rod PQ of length L and with flexural rigidity EI is given is hinged at both ends. Hinge joint is given. For what minimum force F is expected to buckle? So there is a length L of the rod is given, that this is the total length, L is the length of the rod, and this is hinge joint pinned at both points. At 2 points it is pinned, and it is inclined, and if F force is applied and it is roller joint, so it will move in the horizontal direction. But due to this, the reaction will be developed at P point, and a condition will come where there is buckling will start, right? So it means that Euler's load will be achieved, right? Euler's load will be achieved. So we have to find out that force F at which the buckling will take place. This we have to find out. Let us solve this problem.
in this question we are given with an inclined rod PQ at which force F is applied. This F force is applied at this roller joint and this roller joint start moving in this direction. After certain time, after certain load, what will happen is it will start buckling. It will start buckling because the tension is in the rod is certain high that it is exceeded the critical load given by the Euler's theorem, right? So by Euler's theorem, there is developed some critical load in the rod which is causing buckling of this rod, right? So when we are applying the F, there is tension developed in the material in the direction of the column. This is our acting as a column, a pin joint, because simply supports, when we say simply support, it means that it is a hinge joint, right, at both ends. So it is a simply support basically, right? So when force is applied, some tension will be developed in the material like this tension, right? And this tension will be opposed by the tension in this direction here, right? So tension is developed in the material. I can show it here also, right? And there will be some reaction developed here due to earth, due to the load of this, that is suppose RQ, right? And also the angle is given to us, this is 45 degree. If this is 45 degree, this should also be 45 degree, right? So before buckling, just before the buckling, this body is in static equilibrium, and at that point the load was F, right? Suppose just at the before buckling, the horizontal force is F, and tension in rod PQ was T, right? Tension in rod was T. If this is the tension in rod just before the buckling, so that is the critical load, right? So in the direction of the column, that is the critical load, right? So critical force, critical Euler's load, because this is just before the start of buckling, is now, which is given by PC, that is equal to tension, right? Because we are talking about in the direction of column, in the direction of axis of the column, right? That is tension. So we are keeping it tension T by compressing it by tension T, right? And it start buckling. So buckling takes place due to this tension T, and the force, horizontal force in this direction was at that moment was F. So we have to find out this critical load. What is that? We have to find out F, but before that we have to find out PC. What is PC? T. Or we have to find out the relation between T and F, right? And this PC for a hinge joint, both joints hinged, because both hinge column is there. This is a hinge column, and the Euler's load for this column is given by critical load will be equal to pi square EI upon L square. L is the length of the column, and EI is given to us, whatever is the value, right? So PC, critical load, is this, and this is equal to tension. This is equal to tension at the moment before just start of the buckling, right? But we have to find out F. What is the horizontal force F? So we have to get a relation between T and F, right? So how can we get the relation between T and F? Now, if before the start of buckling the body was in static equilibrium, it means that this horizontal force should be equal to the tension in horizontal direction opposed by this. So this is T cos 45. So this force should be equal to this force. So F should be equal to T cos 45 for static equilibrium, and this reaction is opposed by this downward tension of this T, and it is T sine 45. So if the body is in static equilibrium, then these two forces should also be in equilibrium, right? So this RQ should be equal to T sine 45. RQ should be equal to T sine 45. This should be equal, right? So we are not required to find out this, because we have to find out F. What we have to find out is, so we do not need this, we need this thing, relation between F and T. So in the relation between F and T is F should be equal to T cos 45. So F should be equal to T cos 45, or T should be equal to F by cos 45. F by cos 45, and cos 45 is 1 by root 2. So this should be equal to root 2 F. So T should be equal to root 2 F. T should be equal to root 2 F. Put here the value of T and you will get the value of F. That should be equal to root 2 F. So from here we can find out F. The force which can be applied before buckling is pi square EI upon root 2 coming denominator, that is root 2 L square. So this is the answer of this question. This is the answer of this question, pi square EI upon, and this is option C. So the answer is the option C. So this is the answer of this question. The force, horizontal force that can be applied before buckling.